Hello, everyone, and thanks for coming to this session. And my name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I like to bring some of the latest and greatest technology that Google Cloud has to offer, and then also the open source project that we have to the developers all over the world. And this is my very first time here at JBCN, so very happy to be here, and thank you for coming to this session again. And so there are some of the projects I work on. I work a lot with the community and on the open source projects. So for example, I contributed a little bit to JHipster, the code generation tool. And we also started a project called Spring Cloud GCP. So if you ever want to try Spring Boot on Google Cloud, these are a set of starters you can use, which is really nice and very easy to use to take advantage of some of the services. If you have any suggestions, feedback, comment, the best way to find me is on Twitter @Satanism. And finally, the links to the slides and the links to sample code and all the lab and stuff, you can find it on my site at satanism.me. Okay. Aside from development, I like to travel. I love to travel all over the world, and I like to take photos as well. This one is a special photo that I took while I was on a trip in China, in Asia, basically. I was on a 4-month backpacking trip. And there was one city that they didn't allow anybody to stay in the hotel, any foreigners to stay in the hotel. So as a backpacker, I did not have any places to stay that's reasonably priced. And 2 people told me, hey, you can actually go into a desert. And in the desert, if you walk for 4 hours, you're going to find a real oasis, and you can actually stay there for free, okay? And I didn't think twice, because I heard free, and I just went. How many people here hike in the desert before? Anyone? Yeah? Yeah, a few, yeah. Yeah, by yourself? No, yeah. How about walk on the beach? Walk on the beach, yeah. That's it. But it's not the same. It's absolutely not the same. Walking on the beach, you have the water right next to you. Walking the desert, after 2 hours, you look front, there's nothing. You look back, there's nothing. And they told me I have to walk 4 hours in southwest direction. So I happen to have a compass with me. And the thing about the desert is that if you're walking in a certain direction, right, you have to go southwest. What that means is I don't go like left and right, go around the sand dunes. And what I had to do was to go up and down the sand dunes. And the sand is a little bit soft. So every time now you take a little step, your foot sinks into the sand a little bit, and then you have to pull yourself up and take the next step. Anyways, as I was going through it, it was very hard, it was very hot, it was a little scary, and I thought, oh, this feels like writing a J2EE application back in the days. So but the end was beautiful. The end, I got to the oasis. It was absolutely pretty. It was very, very nice. And I think that's where we all want to get to as developers. We want to get our systems into production, but the road to production may not always be easy. And my job, to some extent, is to make this as easy as possible for developers. So hopefully that this session can also help you avoid going through the desert in case of using containers with Java, okay? So how many people here already use containers? Just want to see a hand. Yeah, okay, about half of the room, a little bit. Okay, very cool. So I'm not going to have so much of the intro stuff in there, but I will show you how to build a container and all of the things that you may run into that you have to watch out for. So for example, first of all, why is container important? I do need to speak a little bit about that, right? So for example, here I have a sample application. This is probably the best looking application I can ever write, because I'm not a front-end developer. So this is just black and white, Bootstrap, jQuery, very old school, right? But it has 2 of the best demo application put together. It's got the Hello World and the guestbook, okay? So 2 of the best sample application put together into one. And behind the scenes, of course, to make it a little bit modern, right? It's a little overkill, but just to demonstrate the purposes of it, right? We have multiple components that's actually packaged up into different services in this case, right? So we have the front end and 2 backends, and they talk to Redis and MySQL. Now, typically in the past, when we want to deploy this type of application, especially in the previous Java world where we deploy everything in a YAR file, right? In this case, Even though they are potentially three separate things, but ultimately what we ended up doing is to just code these services directly within our JVM, right, in the same package from the classes directly. And what we had to do was to package all of these jars into the same file for deployment. And typically, if it's a web application, you have the option of a WAR file or a year file, right? That's back in the days. And experience tells me the bigger the year file is, the longer I have to stay up at night to deploy it, right? And also, now all of these application components are tightly coupled together, and so whenever you make a little change to one of these small services, you have to redeploy this whole package, which in my experience, again, I had to, the longest deployment I had to wait was about 2 hours for this thing to start, right? Of course, not this application, but some other ones which has a giant packaging with all of the different components inside. However, that is just one part of the story, right? Where we can deploy an artifact that we know will work, but we have to deploy this artifact somewhere. And we have to give it usually to somebody else who has the control of the environment, who will actually go through the process of procuring the machines, putting them into the data center, hook it up to the network, and then installing the right operating system with the right kernel, with the right system utilities, and then somebody tells them to, what application server we may need to install, which Java version we have to run on, and then finally, with all of that configuration and maybe even additional configuration to the application server with JDBC and JNDI and all that stuff, finally we give them the year file or the WAR file to deploy, and that's maybe like 9 months later, right? And then finally, when somebody deploys it, what happens? Usually, in my experience, this deployment does not work the first try. Why? Because typically there is always somebody on the team, maybe it's you, who actually gets to write exactly how to set up this environment. And you have to write it multiple times. You have to write it for the development environment for your developers. You have to write it for your staging environment, the test environment. You have to write another instruction for the production environment, and so on and so forth. And then somebody else goes and read the long and complicated documentation to figure out, okay, how do I actually deploy this environment? And there's always something that goes wrong, and that's why typically the first deployment don't usually work. And that is just the machine itself. And if you had some of these experiences, you probably run into the fact that, okay, why isn't the connection open? Why is the network not working? Right? Why is there a port conflict? Is the firewall there? So all of these environmental issue kind of adds up, and that's why a lot of the deployment is very difficult to do. And you don't do this to just one machine, you do it to multiple machines. And what we have been doing for the number of years, I've been in the industry for almost 15 years now. For that long, what we have been doing is to turning the machine into something so that you can run one application. And every machine can probably just run one application, right? And if you need to repurpose this machine to do something else, well, typically what happens is you have to wipe it out, and then you gotta follow another documentation with another long and complicated instructions on how to set it up. And this is partially why containers is very, very useful and popular in this respect, because we, as the developers, has the option to actually decide on exactly what the runtime environment should be, so that nobody else have to follow through the same instruction. We can, because these instructions can be executed automatically, and we can actually just put in these setup instructions directly into the way that we build the container images. And so in the container image, what we can say is, okay, what shell tools do we need? Which JDK do I need? Specifically, which application server version do I need? I can put all of these things into the same container image in addition to the application we want to run. Right? So now we have a lot more control. I think that container really empowers the developer to decide on what type of runtime environment we actually need to run the application efficiently and properly. Okay? And every one of these things that you put in could potentially end up in a specific Docker layer, which I'll get into later. But ultimately, what's going to happen is that given a container image, you can just run it on any Linux system potentially that has the kernel that can execute it, and that's it. Now, one thing I want to make clear is that sometimes people say, oh, containers, they're like virtual machines. I'm gonna just say it right now, like it's not virtual machines. What happened behind the scenes is really that they package up all these files, all the application server files, the shell files, and all that into a single potentially archive, right? And then the same archive can be run, just deployed onto any machine that you want. And the application running inside of it is really just a process that you run in the kernel, right? You can actually go into the system and say PS, and you can actually see all the process running. But to the process themselves, to the Java application itself, when the Java application looks outside, all you can see is the stuff inside of the container file system. Okay, it's limited in scope of what the container can actually see. But moreover, what's more important is that rather than running potentially one application server per machine, like what a lot of people has been doing in the past, when you move into an architecture where you have, like, say, microservices, you might actually end up running multiple instances of the application on the same machine, in which case you have to watch out for two other things, which is networking and potentially CPU contention, right? So for example, if you run two Java applications on the same machine, they cannot all listen on port 8080, right? Because otherwise you get a port conflict. So you have to run something on port 8080 and another one on port 8081 and so on and so forth. And now you have another spreadsheet that kind of documents what is running where on what port, which needs to talk to which other services on another port, right? It gets very complicated. But in containers, every container can actually get their own IP address, which is really useful. And so every process in the container can listen on the same port, because they all have their own IP, so now you don't really have to deal with these different IP address conflicts. But more importantly, if one of the processes is taking a lot of CPU, if you don't have any process isolation, the resource that's being used on one of the CPU by one of the process might step over the CPU resource needs of another process. Then the other process might actually just die, or it cannot process the request fast enough. And this had, of course, happened to me in the past in a startup where we run everything on just one machine, right? We had mail server, Apache server, the CGI with Perl script, everything on one machine. And of course, I made a mistake, and Apache process was eating up all the CPU. Then our DNS server died, our mail server died, and everything else died, right? So with containers, we can actually add isolation to how much CPU power the process can actually use, right? So you can say for this particular application, you should only use 2 CPU worth of computing power rather than the entire machine, okay? And this is really, really useful. And finally, just the fact that you have an image that has both the runtime environment and the application itself essentially makes this entire package the deployable, and really it became almost like a static binary of a sort. And this static binary will contain your JDK with your tomcat and everything else, okay? So with that all being said, let me just go ahead and let me create a container very quickly and just show you what might feel like. And then we'll go into all the issues about what I have just done, okay? So first of all, I'm going to write an application. I have nothing here. I'm going to write something very, very quickly with Groovy. I'm going to be using Spring Boot with a Spring CLI to compile this, right? So I'm going to write a very, very simple microservice here, which is called the hello world microservice, whatever. Yeah, there you go. And then I'm going to define a call hello, and I'm going to getting a name. And from there, I'm going to return a JSON payload that's going to say something like greeting and hello from JBCN, and then plus the name, okay? And then I need to map this to a URL, so I'm going to listen this on the hello endpoint with the path of the name that needs to be passed in, right? And then finally here I can do the path variable so that the name variable will be taken from the path, and then hopefully this will return the JSON, right? Everybody believe this will work? Wow, nobody. Okay, no one thinks this will just work. Neither do I, so I have no idea. So let's see if this works. Oh, wow. Okay, that's not bad. Ooh. Yeah. Okay, so that's a good sign. It is running, right? So let me go ahead and go to localhost 8080. I'm gonna say hello, right? And okay, not bad. Everything works. That is pretty simple and straightforward. Now, assuming you have something else like a Maven project or a Gradle, you do a very similar thing. But ultimately, what you need to do is to create the package, like the jar or the war. Now, I need to do a poll here. How many people here deploy into an application server like Tomcat? Anyone? Okay, overwhelming more than half. How many people here just deploy into a jar file and then just do java-jar? One person, interesting. So the other half of the room does not deploy at all. Is that? Well, no, maybe not. I'm just kidding. But let's say because there are more hands-off for Tomcat, so I'm going to do this demo with Tomcat specifically. Okay. So first of all, I can turn this into a war file. So I'm going to do that. Again, with Maven, you do it differently, right? You just do a Maven package. But in this case, I can create a war file just like that. So there's the war. And it is actually a self-executable war, but I can also deploy this into Tomcat. Okay. So then what do we do? Now, typically, what we ended up doing is write another instruction to tell potentially a separate team, like, oh, okay, I need to run it on, say, a Debian base image, right? So somebody says, okay, I need Debian, right, as the operating system. And then we say, okay, we need to maybe install something. Somebody needs to install, like, open JDK-8-jar, right? And maybe I need to install something else, so it doesn't matter. And then I can copy my file into this container image. I need to copy the file into the machine, right? So in this case, I can say copy hello world into a specific path. So I can say hello world.war, right? And then finally, we need to tell potentially the team, like, how do we actually start this application? In this case, I'm going to say, oh, I need Tomcat, okay? So what that means is, okay, how do I install Tomcat, right? So we go ahead and say install Tomcat. Where do we get Tomcat, right? So as you can see, we can actually write all of these instructions in the Docker image, right? So we can write these instructions down to reproduce this environment, hopefully consistently, right? So we can do this, and then we can say, now I have, I'm going to say wget, for example. So I'm going to install wget here. Let me get curl too. I'm going to say tar xvzf, this whole file. And that's going to put this unpacked thing into a directory. And I copy the war file into this directory, which is going to be Apache. So you can see that we can go through this exercise until we have this entire thing up and running, right? So for example, I need to put the war file into the web apps directory. And then finally, when we run this Tomcat environment, I think we do something like, does anyone remember how to start Tomcat? Anyone? No? Nobody starts Tomcat here. I think it's catalina.sh, right? And then start, I think. That's it, right? Something like that. And we're done. All right? So that's all the talk I have. Thank you very much. No. There are so many things wrong with this file. Well, first of all, I don't even think it works. But even before it works or not, there are so many things wrong with this, right? I'm just going to point out a few things. Number one, on the top, from. So what this will do is for instruct Docker to download a base image that will lay down the basics of the file system, okay? So rather than somebody else to do it for you, you can actually instruct Docker to do it, and when you build this image, you actually go and get Debian base image, and then lay this down, and then everything else you do will be on top of that base set of files, right? So you have the base set of files from Debian, and then you have apt-get install, which you install the JDK, the wget, and then you add more files into this entire image, into this giant static binary. Now, the problem with this, very firstly, is that when you say from Debian, what version of Debian is this actually going to get? Well, it's going to get, by default, it's going to inference Debian latest. Okay? So you would think that this is the latest version of Debian, or sometimes you do latest Ubuntu or latest something else. However, the latest could be different depending on when you actually pulled it. Okay? So for example, if you ran this file and you pull Debian latest, say from a year ago, that could be Debian from a year ago. And if you didn't do any cleaning up in your machine, if you didn't force it to download the newer one from today, it will continue to use the one from last year that you tried. Okay, so it's always very, very important to be specific in terms of what version of the image you want to use. Okay, so first of all, I'm going to do Debian stretch, for example. That's one of the versions. That is also potentially very dangerous, but this is the best thing I can get on Docker Hub, for example. So sometimes we see something like you can also use something that has JDK pre-installed. So you can say something like OpenJDK 8 as the base image. So this would have the base operating system files and also the OpenJDK 8. But the question is, which 8 are we getting? Is it OpenJDK 8, 171, 142, or 151? Well, we don't know. We don't know unless if you specify it in the image, right? And not all of the images give you this type of specificity, so you have to be careful on what you actually pull in. Okay? So the from, you gotta be very careful in terms of what version of the base image you want to use, because a lot of people say that the images are immutable, like this is the package that you deploy. But in this case, it is not so immutable anymore because it really depends on when you actually build the application. Now, the second thing here is we do run apt-get install, OpenJDK and wget and curl. This thing will probably fail as is. This is probably the instruction that you will actually tell to a system operation or a system admin. But because this is going to be executed in a script, automated, if you just run it as is, it's going to prompt you with a lot of questions. Like, do you want to do A, or do you want to configure it this way or that way? And because when we actually go to this build, it's all automated. There's no way for Docker to actually ask you questions, so we actually have to say yes to everything potentially, okay? Or there are other ways for the system to configure it with specific values, so we have to be careful. But before we can do that, we gotta do an apt update to actually grab the latest image, right? The latest packages, and then we can do the install, okay? And then we do run the wget, we unpack it, and we copy the WAR file into web app directory, right? And hopefully that's going to work. I actually don't know if this is going to work at this very moment, so I'm going to do a build, and let's find out. Hello world T, right? Unless if somebody can tell me how to start Tomcat at this very moment. Did I get it wrong? Anyone? No? Maybe? All right, so as you can see, this is running through the instructions, right? It's going through all of these run commands one by one. It's doing apt-get update and then get install. So hopefully you will have OpenJDK and wget and curl. And then finally, once this is all done, hopefully I'm going to get Tomcat here, and then I'm going to unpack it. And it's going to unpack it into Apache Tomcat directory. And then, yeah, I think I feel pretty good about this right now, but we will see. And as you can see, this whole thing is going to take some time to install, right? Because it is kind of setting up from a clean scratch of a container image that has nothing and slowly installing everything into it. Okay, so now I'm really nervous. I don't know if that's a good thing or not. But once this builds, if it actually works, I'll be amazed by myself, and then I can move on to the next part of this thing. Oh my goodness. So it actually built, okay? So I'm going to run it. So I'm going to say docker run. So now I have the container called hello world. So I can say docker run hello world. I'm going to add TI so I can terminate it if I want to. And then just for completeness, I'm going to bind the port. So what this is going to do is to run this container binding to the localhost port 8080 that will connect to the container IP address and then connect to that 8080, right? Because every container has their own IP. It's not running on your local host, so you actually have to do this port binding explicitly. And so let's see. Oh, did I? Oh, you know what? I think I don't think it's start. I think it's actually run. Because I think start runs it in the background, and run actually runs in the foreground, right? But regardless, I think I have, no, I don't. So let me do this build again, right? Is it run or start? I think it's run. Yeah, well, we're gonna find out pretty soon. So what this is going to do is to rebuild this container again. Now, what is really interesting, of course, is that rather than downloading and doing the apt-get and the wget over and over again, what has happened behind the scenes is that every one of these command line is actually going to create a file system layer that gets laid on top of the previous file system layer, okay? So for example, I started off with Debian file system, which has just the Debian base files. And then I do a apt get update that's going to download the package metadata. And then so that's going to have another file system layer with just a couple of files, but that lays on top of the previous base layer. And now in the whole view, you get to see everything plus the file you just downloaded. And then we do an apt get install. So it's going to build on top of that the previous two layers and add another layer that has OpenJDK on top of that. And then finally another layer that has wget, another layer that actually unpacks it and copy and all that, right? But we actually cache the layer by default. So Docker will say, oh, did anything change for this particular command line? apt get update. Well, no, nothing changed. So I'm not actually going to rerun this command over and over again, right? Because the file is already in the file system. There's no need potentially for me to re-download everything. And similarly, when we say apt get install, the command line did not change, and so it doesn't actually execute this command, and it just uses whatever was previous built. Now, as you can see, this can also be potentially dangerous. Why? Because if you built your container on your machine 2 weeks ago, you're going to get the package metadata from 2 weeks ago. If somebody else builds the same image tomorrow, they're going to get the latest package from tomorrow. And so OpenJDK 8, again, which version of OpenJDK 8 is it, right? So we have to be very careful with Docker images, because if you don't do this right, it's very, very easy for two or your entire team, like 10 people, to build images that one of them works, the other one don't, partially because that the environment that we built from can be different, even though they are coming from the same file. So it's very important for you to also remember to set pin the versions in your files so that you always know which version that you are dealing with, right? And because I didn't change anything, right? So this is very dangerous. If you want to force the image to always pull down and execute everything, what you can do is to say when you're building, you can say something like no cache. And what that means is it's not going to use the cache on your local system, and it's actually going to re-execute the whole thing again, okay? And that is probably the best way to build from a CI/CD server, because otherwise your CI/CD server will be depending on caches that it was pulled down from a year later, or from a year before, right? And if you never go and update these caches, you're always going to be running on outdated environments, all right? So be careful. So let's run this again. So I'm going to say docker run. And hopefully it's catalina.sh run. Oh, yeah, it is. Okay, very good. And it should be binding to port 8080 and deploying to the context path of hello world. And let me go ahead and see this thing running, hopefully. Hello world. Oh, I have this cached here, right? So let me see if this is running my Docker environment, Docker machine, hello world, and that works. Oh, thank goodness. Not bad, not bad. So this is actually running in my Dockerized environment in a container image, right? Instantiating it. I can run as many instances of this I need. I can send somebody else this image. It will just run exactly the same, which is fantastic. But there are still a lot of things that is wrong with this particular image, okay? There are a lot of not so good practices in here, okay? So first of all, remember what I say about the layers. So every time you do a from and then do a run, every one of these commands will generate a new file system layer that actually has the file, okay? So in this case, well, I can see that, well, maybe after I do a wget here, I untard it, and maybe I can go ahead and do rm, right? RF that? No, not that. You delete that one, right? And maybe you say, okay, so I can probably save some space, right? So if we do this build again, we'll see what happens. So it's going to run through the same instructions. It's going to cache, so it doesn't run the same thing over and over again. But it will go and delete the tar.gz file, right? And you would say that tar.gz was maybe, say, 80 megabytes large, so you are saving it up 80 megabytes of data. So let's see how big this image is. So if I can do this with Docker history, I can potentially see Docker history hello world. And here you can actually see all the different layers that we have actually created, okay? So every run command is recorded here, and we can see how much data every run command has used. So for example, my base image from Debian is 100 megabytes. And then I do apt-get update, that's going to download 16 megabytes of metadata. And then I do apt-get install, that's, wow, 417 megabytes, right? And then I download Tomcat, that's 9 megabytes, that's not too bad. On target, it's 13 megabytes. And then the REM didn't really do anything. It actually did not remove the previous layer. Like, what happened here is that in the file system view that's being aggregated for your container image, you will not see the tar.gz file. That is because the layer says that it's being deleted. However, the previous layer that you have depend on still has the file inside, right? So you still have 13 megabytes there. This aggregate is actually the total size of the image that you have just created, okay? And finally, you have this, this WAR file that's 21 megabytes large. So not so good right now, right? It's a very, very large image, and there are a lot of things we can do to potentially optimize it, right? So for example, it is typically better for you to run some related command lines in a single run command, okay? So for example, here, when we say apt-get update and then run apt-get install, right? They will pull down 16 megabytes and then 80 megabytes of data. It's better actually for you to run these things together. So this is what I would do instead. So I would say end, and then I do the install. And after the installation, it's always better to clean up afterwards as well. So for example, here I can say apt-get clean, and then I can delete the caches that was downloaded by apt-get update, right? So I can do something like var lib apt list. So I delete the cached data. And this will generate not 3, 4 layers. This will just generate 1 layer. And the aggregate of the command that you have done here is going to result in the final layer that will be the size that you get, right? So similarly here, for the run command, right? Rather than running these 3 things in 3 separate run command, if you actually combine them into a single command line like that, then you will not have multiple layers. You will just have 1 layer, and that layer will just be the size of the expanded Tomcat, what do you call it, file size, right? So let me do this build again. We can see that by doing this, we'll reduce the number of layers and also reducing the size of the image. Now, another tip here is that if you actually go through this process using apt-get, sometimes this install will install a bunch of unrelated things. If I scroll back, you'll probably see that this has installed X Windows and a bunch of other things. So to reduce the needs for certain applications, we can actually add this thing called no install recommends. Okay, so that is going to install only the bare basic necessities and not any of the recommended packages. And this all together will hopefully help me to build a little bit smaller image, okay? So let's see if that actually works. And there we go. Now, there are 2 other things I'm doing very, very badly in this demo, okay? I'll show you once this is done. But if I scroll up here, if I see this build, and I say apt docker build, there we go, docker build-t hello world. Again, in this particular case, I did not specify what version of hello world this is. So by inference, this will always be the latest. And again, in a development environment, and especially in your CI/CD, this is going to be problematic. Because again, the latest from yesterday may not be the same as the latest from today. So you always want to tag the image with some kind of versioning scheme. In a CI/CD pipeline, you probably have build numbers. If you are using Git or whatever, who's not using Git today, right? If you're using Git, hopefully you are, right? You can actually add the Git commit ID to your build tag as well. And this will then uniquely identify this particular image coming from a specific source set. And then you can actually deploy the right application. Otherwise, you could be deploying the latest, which you have no idea which version that is. Okay? So now I have built this thing, and if I do Docker history, you can see very clearly that this apt-get install rather than 400 megabytes now is reduced to 300, right? And the wget here, because I am downloading and extracting and deleting the archive, so I'm not actually using multiple, I'm not actually having twice the tomcat the size, right? And now this is a little bit reduced. Now, if you notice, when I say docker run -ti and then bind it to the port, and then I say the name of the image I want to run, this is also problematic. I don't know if anyone here who has used Docker ever run into the issue of running out of disk space. Anyone? If you use Docker for more than 2 weeks, if you run this command line every day, you are likely going to run out of disk space. What happened behind the scenes is that every time you run a container image, it's going to potentially extract the content of the archive, potentially the latest layers of that, and put it onto your file system, okay? And then Tomcat might actually write some additional file into the container file system as well. So when I do this, for example, it's going to potentially unpack, create a new directory with the file system, okay? And then Tomcat may be outputting logs into that file system, okay? And then everything's running, everything's happy, right? I can run, I can test. As soon as I stop it, right? I go to Docker PS, the Docker container is not running anymore, but the file system is still there. And a lot of people don't see this until they run out of space in their file system. What happened here is that Docker do keep track of all the containers you ran before, unless if you explicitly delete the files. And the way we can see it is by saying Docker PS, there's nothing, but if we show all of them, then we see everything that is still there. And we can actually see all the different Docker containers I have ran from the past. And for every one of these containers, there's a container ID. I can, if I want to, start this container again from a previous instantiation of it, right? And if I do it this way, it's going to go back to that file system, start the process, and it's always there. And this is why, for a lot of people, they will run out of disk space. And we can actually see that this is up and running, and we can actually go and see this application. Problematic. So if there's anything that you would take away from this talk, the number one thing is when you say run, always use --rm, okay? So if you do it this way, it will run the container, you'll unpack, it will generate this new file system layer, right, which is specific to this particular container. But when you exit, it will actually delete the container for real. But otherwise, it will just stay there forever until you run out of space. Now, if you do run out of space, there are other things you can do. There is something called the Docker image garbage collector. There are two of them. Well, first one is within Docker, you can do a Docker system prune, and that's going to find these unused image layers. It's going to clean them up for you. There's another one called Spotify GC. So this is a tool created by Spotify that will actually help you garbage collect container images that's there, but it's not being used by anybody. And these two utilities are really useful if you do run out of space. But you can avoid that if you just do the --rm, okay? So everything's up and running. We're good, right? This is a smaller image. Everything's working. We're done. Almost. Yeah. So for example, oh, wow. Did I take that? Okay. Oh, that's interesting. So for example, one of the things that people don't usually do is that they don't notice is that this is actually running in root, okay? So one thing that you have to remember is that Docker is not a security boundary. What that means is that when you run Docker, it's just running as a process on your system that could potentially be isolated by other Linux security constraints, but it is not a virtual machine, so it is not a security boundary. And by default, a lot of the images that you use from the internet, they always run things as root inside of the container. That is not good at all. So for example, in this case, this is all running at root, which is not something that you should be doing at all, right? So just be very careful with it. And there are always ways for you to kind of run it as non-root. So for example, first of all, you need to add a new group, like say nobody, and then you can say user add to nobody, like my app, for example. And then when you say run get all of these things, you have to specify the user you want to run as. So I can say user app, right, and so on and so forth. And ultimately, when this thing runs, it's going to run as a user code app that's in the group of nobody. So just be very, very careful with it. Now, specific to Java, though, there are a few other things we need to talk about. When we do run this Java process, there are two very, very major issues with Java, especially in Java in JDK 8 and 9, potentially, and 10 is slightly better. So for example, in Docker, we can say, let me see here, -m, 1G, yeah, there we go. So here in the Docker run command, what I can say is, I can run my image code, in this case, OpenJDK, I'm going to run OpenJDK 8. We don't know which version this is, unfortunately, right? But here I'm saying that I need to restrict this process to 1 gigabyte of memory and 4 CPUs, okay? However, in most of the OpenJDK JVMs, what is going to happen is that if you don't specify any heap, it's actually going to see the size of the machine, the memory size of the machine, and use that to calculate the default heap size, okay? So even now, even if I'm using -m 1 gigabyte, so what that means is if my process uses more than 1 gigabyte, it's going to kill the process for me. And this is where you actually get the out-of-memory errors from Docker or in Kubernetes for your Java applications. But because I did not set any max heap, this is actually going to use up, I have a 16 gigabyte machine or 32. So let me see how much is this in gigabytes. So this heap size is now defaulted to 27 gigabyte, right? And we all know that Java will probably use this up very aggressively. And as soon as you cross over the 1 gigabyte threshold, you're done. This process will be killed, right? So gotta be very careful. It's always better for you to explicitly set the number of the max heap that you want, okay? And the max heap cannot be 1 gigabyte either, because in addition to the heap, you also have the native memory that Java actually uses, and the perm size as well, and also the threads and all that will take native memory. So you gotta be able to calculate exactly how much heap that you can use and how big the system memory you actually wanna use, okay? And similarly, here I'm restricting my process to use only 2 CPUs, okay? But similarly, Java mostly do not understand what this CPU is, right? So if I actually say, if I see grep thread, what I'm trying to do is to find the GC thread that is being used by parallel GC. So in this case, the JVM also picked up 16 threads or 16 CPU from my machine, so it defaulted the parallel GC thread to 13, which is also not very good, right? And moreover, if you actually have an application that uses this thing, so it's called the runtime get available processors. A lot of the code that I've seen uses this particular trick to figure out how many CPUs are actually in the system, and based on the number of CPUs, we derive the number of threads that we want to start, right, in the thread pool. This will also return you the number of CPUs on the host rather than the number of CPUs that's specified by Docker. So if you're not careful, again, you could be running your container on a 32-core machine, but you only assigned 2 CPU to the container. But if you're using this line to figure out how many threads to start, you could be starting 32 threads rather than just 2, right? Because this number does not return you the number of CPUs that you set in Docker, okay? So for example, let me try to build this very quickly. Docker build -t processors, right? Dot. So I'm going to hopefully be able to build this container very quickly. Yeah. And if I say docker run ti processor --rm, right? Oh, rm like that. Oh, come on now. There we go. Whew. Okay, so if I do docker run so you can see that get available processor is 16. Similarly, if I say CPU is 2, it will probably still give you 16 as well. Well, it actually gives me 2 because I'm using JDK 10. So it's actually the version that actually works. If I build this with Java 8, which is what most people are using, I believe, and Java 9 has similar issue, but that's okay. You shouldn't be using Java 9 anyways, right? So if I do Java 8, if I do the run again, in this case, it should also show me 16, right? So you gotta be very careful with that. So you should always ping the potentially know how many CPUs you need. You should pass that into your Java application, especially if you're using Java 8. Similarly, for the memory, you should always make sure that you set the X and Max. Now, there are some tools out there that can help you to do this. Give me 1 second. This, for some reason, I think we started a little late. So let me see here. Where did it go? Yeah, so there are actually some really nice scripts for you to use to set some of these default values. One of them is from Red Hat. It's called, well, from Fabric 8. They have a run script that will say run Java SH, and that's going to make the XMX calculated heap size for you, and also set up the, that was Siri, also set up the right number of processors for your parallel GC, okay? Now, if you're building it from a Maven or Gradle build system, there are a couple of container builders that you can actually use to make this process a little bit easier, so you don't have to write Docker run commands or build commands yourself. One of them is actually, the Spotify has 2 plugins. They have a Docker Maven plugin, and then I think they have a Maven Docker plugin. Now, one of them is the one that you should be using. So Docker Maven plugin, if I recall correctly, is not the one that you should be using anymore. What this does is to actually specify the image manifest exactly what the base images are and so on and so forth directly inside of the Maven configuration. And it's going to generate the Docker file for you based on this, right? But Docker file is just a lot more flexible when it comes to using Docker. So in that case, you should actually use this other plugin called the Docker file Maven plugin, okay? So if you're ever using Docker Maven plugin, you should probably look into switching over to Docker file Maven plugin. What this will actually do is to use the Docker file that you create and use that to build an image. Now, the real benefit of it is that if you have a fat jar, if you're building a fat jar, every time you deploy this jar into an image, it's going to be 20 megabytes, 80 megabytes large, right, or something like that. But most of the jar file is actually going to be composed of dependency libraries. And the dependency libraries don't usually change. So what this plugin allows you to do is to write a Docker file that actually allow you to add dependencies into its own layer, right? And because the dependencies don't change often, then this layer do not have to be recreated all the time. And every time that you create the new image, it's only going to modify the actual jar file, which could be just about 100K or so. In this way, even though the entire image size is the same, but every time you deploy, it can potentially be a little faster, a little quicker to do, okay? And finally, we do have another plugin that you can actually use. This is for people who don't actually want to install Docker on their own machine. There are plenty of different ways to build a Docker image without using Docker directly on the machine. And so we actually built a tool called Jib. It's actually short for Java Image Builder, okay? So what Jib can do is to allow me to build a Docker image for a Java application without actually potentially having Docker on my machine. And all I need to do, again, is to specify potentially the plugin, right? And I can give it the destination. So in this case, if you don't use Docker on your machine, you actually need to build the image into a Docker registry and uses the registry API to actually create the image for you. And to do that, we can do something like Jib build. And this will build the Java application for me, and also creating the layers smartly behind the scenes, and then pushing the layer directly to a Docker registry, and that will be ready to be consumed. Okay? And I can just go ahead and, if I want to run it, I do need Docker to run it, so I can just say Docker pull. I can pull down the latest image, and I should be able to just do a Docker run with the RM, of course. And that will start this application for me. It automatically figures out the startup command lines that I need to use to start my application. And you can build this very tiny image behind the scenes, okay? So there's definitely a lot more I would love to talk about, but I think I'm pretty much out of time. So just the one last note is that if you do use Docker images, if you do deploy Docker images, one thing that you do need to be sure of is please don't SSH into your machines and do Docker run on them to deploy your production system. It is just not good because just one last note is just that if you want to use Docker in production environment, just make sure you use a container orchestration tool, something like Kubernetes, that can help you manage and deploy your applications across multiple instances in your entire cluster. Okay? And without that being said, you can find the content of this talk on my site, saturnism.me/talk. And thank you so much for your time. I really appreciate it. Okay? Thank you. Oh. There are definitely things I wanted to talk about, but yeah, I ran over. Yeah, please. Yeah, questions? Yeah, sure.
Someone have some question?
I have a couple of questions. First of all, I'd like to know, the first line of your Docker files, it's about downloading the Debian image or whatever, okay?
Yeah.
So I'd like to know what does happen. I mean, I understand that it downloads it from some server on the web. What does it happen if that server is offline or you have any restrictions on your production environment to get there?
Yeah.
If you can, I don't know,
exactly.
use some kind of own server for to catch all these things.
Yeah.
And the other question I have is, I usually use Spotify to listen to music. What does it has to do here? I mean, okay.
What's that?
I've read the Spotify thing a couple of times.
Yeah.
I mean, is the Spotify doing something with Docker or something like this? Okay.
Okay. So Spotify is using Docker. That's why they built some of the tools surrounding it. And as far as I know, they use the Docker file Maven plugin themselves, right? But I cannot speak on their behalf. But I know they built the tool, and they do use this in some respect, right? As far as this particular thing on the top, the from. Definitely, I think some of the organizations I know definitely has some kind of issue about pulling some images from the internet, and you do need to potentially patch it up, or you might even want to build your own base image at the corporation level, right, at the enterprise level, and you can do that, right? So any image that you create, like for example, typically, to make things easy. If I want Java, I will just say from OpenJDK 8 with a specific version. Then I don't really need to deal with these other things. I can also just pull in the tomcat image here, right, and say tomcat 9, and I just copy it into the right directory. Then I'm done. The question then is, well, what is actually inside of this image? Who built it? And are they actually safe? Who keeps up with the vulnerability checks? And there are a lot of questions around that. And to answer this, well, typically what I've seen is people end up building their own image, right? They typically end up building their own. They do their own patches. Then they create their own container image like that one, which has their Tomcat version installed that they know is going to work. They patch everything up directly. And then finally, they build this into, let me just get rid of this WAR file. They build this into, say, build-t my tomcat 9, right, and the dot. And then other applications will then use your own container image as the base image, right? So now I can actually write another file, like this one, Docker file. Oh, sorry, Docker file demo. And I can say from my tomcat 9, and then I can copy my WAR file into my web apps directory, right? So that's one way for you to have really good control on what actually goes into the image. And I do see a lot of people have issue with the public images, right? Because we don't know who built it. Potentially, are they running as root? Do they have the right patches? We will probably end up building your own. And most importantly, actually, one thing I didn't get a chance to mention is to say that you should always run some kind of container security analysis tool, because the security enforcement is no longer just on the machine itself. It could potentially be inside of your container, right? Because your container could be using like libSSL or some kind of library, shared library from the Linux file system that actually has some kind of vulnerability. And you need a way to have this end-to-end view on what's actually inside, and through all the layers, like which one's actually being used, and finally determine if there are any CVEs, and then you need to patch it. And the way to do that, there are some tools out there. One of them is JFrog has X-ray that can actually scan your container images for you. And Google also will have something very similar that's in beta right now, I believe, or alpha, that can help you scan the container images. So you do need to be careful with what actually is inside of the image. Okay, so hopefully that can help you answer that question. Yeah. Okay, thank you. Yeah. Any other questions? I don't know if we still have time, because I think mine's until 1, right? Yeah. Okay, good. Well, yeah. Oh, thank you. Cheers.